Hello, we are going to learn to solve a quadratic by graphing. What does it mean to solve? Well, first of all, it means that we're going to find the zeros, which are the same as the roots or solutions. And first, we're going to warm up by doing a couple of factoring problems. Factoring completely. First step, check if there's a number you can divide or something that you can divide all the terms by. These two terms can be divided by 5, so we factor out a 5 and we get x squared minus 4. We then look in the parentheses and we say x squared minus 4 is a difference of squares, which can be factored. You should know that one. The x minus 2 times x plus 2, again, you can switch around which way you have that written. That would be fully factored now. Number 2, each term is divisible by 3, so we factor first a 3 out. And we get 2p plus 5p plus 3. Then we need to check if we can unfoil or factor 2p. I should have a squared on here. Excuse me. If we can factor the 2p squared plus 5p plus 3. You can. So I try it though. Let's check. Maybe we can't. 2p, the factors of 2 are just 2 and 1, so we have to have 2p and p in those positions. There are only two factors of 3 and 1. I need to know where to put the 3 and where to put the 1. These are all addition up here, plus plus in my original problem, so these have to both be addition. Not necessarily the original, but in this right here, since both of those are addition, these have to both be addition. You can't have the signs opposite because then the end term would be negative. You can't have the signs both negative because the middle term needs to be positive. So that's why it's plus plus, going to match. So then I say, well, where do I put the 3 and the 1 so I can get a 5 in the middle? Well, if I put the 3 down here, I'm going to get 2p times 3, which would be 6. That's too much. So I'll put the 3 here, put the 1 here. Now I'll have 2p plus 3p. That's where the middle term comes from. The sum of the last terms multiplied and the inner multiplied. And then 3 times 1, I verify, is positive 3. That's fully factored. Okay. And number 3, each term can be divided by 2 and an a. So I'm going to factor out a 2a. 2a squared divided by 2a would be a left over. Another way to look at it is a times 2a would be 2a squared. Plus 8a divided by 2a is 4. And then you can just double check and make sure that if you redistributed the 2a, would you get back to the original? And the answer is yep. Okay, that's done. 4a squared plus 4a minus 4, you can only factor out a 4 from every term. X squared plus x minus 1. Yes. Where? This doesn't have a 4 on it. You can only factor the most each term has. Or the least. Like meaning, okay, I can't divide this term by 4, so no. Here? What? How? There's no 4 on the a, hun. No 4 on the a. Okay? Do you get what I'm saying? These are like that's 1a plus 4a. So you can't simplify that, nor can you factor anything away because they have no term in common. Now, we got to check if we can factor this trinomial here. I'll tell you right now, there's no way. Because the factors of x squared would be x and x. Factors of 1 would be 1 and 1. And no matter what I do with the signs, if I make them opposites, then there wouldn't be an x term in the middle, right? If I make them the same, you're going to get 2 something in the middle, okay? So you can't do it any further. Bringing it all together. To solve a quadratic equation when you're multiplying, how can you get an answer of 0 when you're doing a times b? Well, then a must have been, one of them has to be 0 for that to happen. So here's the point. When we factor, we do set it into a product of two things. We're going to set those factors to 0 and solve. So I'll show you. So for this one, we're going to factor this into a binomial times a binomial. But notice the difference. These are set to 0. We're not just factoring, we're solving now. So when you see the equal sign, we're going to be solve for x. That's what we're doing. Which is, again, going to find us the zeros. I think I'm supposed to, is it ES? I always think about that one because it looks weird to me when I'm writing this. And that doesn't even look like an R. I think it's zeros. Roots means the same thing. Solution. All of those mean you're finding the x-intercepts. There's the other last way to describe it. Or x-intercepts, where the graph crosses, the quadratic crosses the x-axis. If it doesn't cross the x-axis, these things won't factor, and we'd have to find another method, which is coming forward in another day. X and x, I need to think about, now this is how I mess around with factoring, or did, it's what my little method. I take the 18, that's the only one I got to worry about, because I know it's got to be x and x here. I say, what are the factors of 18? 18 and 1, 9 and 2, 3 and 6. And then I think, which pair of numbers can get me a 3? Yeah, 3 and the 6. So I'm going to use the 3 and the 6. And then I'm going to determine the way to do the signs. So I say, well, one of these was addition. One of these was subtraction, or minus. So if I need a negative at the end, that means one has to be positive and one of these has to be negative, right? And the one you want to be positive is determined by what's here in the middle. It says plus 3. I want a positive 3 out of adding 3 and 6. So I make 6 be positive, I make the 3 be negative. Okay, that's basic factoring. That's the easy kind. All right, it's a little more complicated when we have a leading coefficient other than 1. Now, what you do now is, remember, it said in that property I just looked at with you that the zero product property says that if A times B equals 0, either A or B is 0. So what we're going to do is we're going to set each one of these to 0 to find out the answers that would make each one of those 0. So you set each factor, x minus 3 is one factor, and you solve it, and you get x is 3. You take x plus 6. This is why in that format I showed you before, remember it was intercept form, you had to graph the parabolas on the quiz. It was x minus p, x minus q. It's always the opposite. Okay, so this would give me negative 6. So now I found the two solutions. This parabola, when graphed, would cross the x-axis at negative 6 and 3. And then you could find the vertex by averaging these two and plugging in. Sixth, first step, set it to 0. Can't do it the way it is right now. So 2r squared minus 20r plus 50 equals 0 would be step 1. I just went and subtracted 3r and added 5. Now I'm going to factor out a 2. Okay. Now I'm going to factor the trinomial. So I say, okay, I got a 25. That's a perfect square number. 5 and 5 adds up to 10. So I know it's going to be x, 5, x, and 5. Then I say I got a minus sign right there. Both of these need to be negative then. Because a negative times a negative is a positive, I know the end is correct. This is how you have to think when you're factoring. You got to check and see if your solution's correct. These cannot match. You would not, or they can't be opposites. You would have no middle term. It have to match, and it has to match that sign to get a positive at the end. All right, so then we say, okay, I only have one factor really, because I have solve this twice. And then you might say, well, what about that 2? I'm just getting a double. This is called a double root. Okay, and you might say, well, what about that 2? How come you didn't do anything with that? Does it have an x on it? Can you make it a 0? No. Okay, now I'm going to explain to you, and you don't have to write this down at all, but I want to talk to you about this for a moment. If you graphed x minus 5 times x minus 5, this is what it would do. At 5 on the x-axis, it would bounce. That's what a double root does. Okay? You're going to need to know that later when we get to more stuff about polynomials. However, right now, just let me explain to you why the 2 doesn't matter. Because if this had a 1 for an a value, it would just be a normal shaped parabola like I have here. What does that 2 do to that parabola? It makes it narrower. So it's still bouncing at 5. There are infinite number of parabolas I can write with this vertex. I could put a negative 2 in there. Then it would go that way. Get me? Still has the same roots. It still has the double root of 5. I could do wider ones, like have a fraction in front of there, okay? But it still have double root. It's the a value just makes this graph skinnier or wider. Okay? You don't need to write that down at all. Just thought I'd bring it up. I will bring it up again in the future. All right, let's factor out on this one a negative 2. So we'll have b squared minus b minus 30. Okay. Next, we'll need to factor out, or factor. I already factored out the negative 2. Factors of 30, I'm going to go with two numbers I think about all the time when I think of 30 as a product. It would be 6 and 5, numbers that multiply to give me 30. Since I need a 1b, but I need a negative 1b, so I'm going to make the 6 a negative and the 5 a positive. Now I've got negative 6b and 5b will give me negative 1b. I have negative 6 times 5 is negative 30. I know I factored it correctly. So I say b minus 6 is 0 and I get a solution of 6. I say b plus 5 has to be 0. That would give me a solution of negative 5. 6 and negative 5 are the solutions or roots or zeros of that quadratic. Anybody need this? Okay, next one. What is this? We want to know what it's called. It's a difference of what? Yeah, difference of squares. If you factor a difference of squares, that one should pop into your head. These are perfect square numbers. You know that it's going to be unsquaring of the front and the back. It's going to be 2x minus 5 or plus 5 if you like to start with that. And then the other one's got to be the opposite in the middle only, not the conjugate. It's a conjugate, not the full opposite. Okay, so I've got two solutions coming up here. I'm going to solve for 2x plus 5 equals 0. That would give me negative 5 halves. And then I got to solve the other one. And some of you probably won't write every one of these steps, of course. It's 5 halves. I want to show all the details because this is our first time doing it with factoring. All right, so far so good, I hope. This next one, this is called a perfect square trinomial. The last number, 144, is a perfect square. 12 times 12 is 144, and 12 plus 12 is 24. That's how I recognize it as a perfect square trinomial. This will be x plus 12 times x plus 12. Okay, and that's the kind that has a double root. And x, that would be x is negative 12. Do you want to identify a double root? 10, common term to both. This is the kind, guys, that we messed up on that quiz with factoring. I don't know what we're messing with calculators for. Let's do factoring. Come on. Okay, what's in common to both terms? 8. Okay, you can divide 28 by 24. So, and you need to pull out a x. They both have x in them. So we're going to do 8x times x minus 3. Oh, hey, the thing we pulled out wasn't just an 8, so it does matter. It's got a variable on it, right? So we have to set 8x to 0, bless you, which gives us, bless you, 0 for a solution. The other part gives us 3 for a solution. So there are answers of 0, guys. It can cross at 0, 0. X-intercept of 0 and 3. Any questions about that one? Okay, so if there's a number only pulled out, now then it's not going to be set to 0. All right, let's go with factoring this guy. This is getting where some of us still are having a lot of trouble with factoring. The factors of 6, 6 and 1, 3 and 2. The factors of 2, 2 times 1. So you're going to say, all right, I need a 13 in the middle. I got to work with pairs. So it's either going to be 6 and 1, 2 and 2 and 1, or 13 and 2 and 2 and 1. Well, that's not a 13, that's a 3. Excuse me. 3 times 2 would be 6 and 2. 6 and 2 is not going to get me a 13. Neither is 3 times 1 and 2 times 2. That's 4 and 3. So it must be 6 and 1. 6x and x. And actually, I thought of that one because I see 6 times 2 is 12. And 1 times 1, 12 and 1 gives me a 13. So I need the 2 at the end here. So I can get 12x. Okay, and then I'll have a 1 here, which is a 1x. Now, what about signs? Since there's a plus at the end, these both have to match. That's not the only reason they have to match. You need to get a negative 13 in the middle. So negative 12x and negative 1x, you need minuses on both of these. So you've got to verify it, 1x and negative 12x, that's going to add up to negative 13x. And negative 1 times negative 2 is positive 2. So now we set these to 0 and solve. So we get 1/6. And for the other 2. Pretty slick. All right, number 12, a little more complicated factoring. 15 has factors of 15 and 1, 5 and 3. Usually it's the close together ones like 5 and 3 unless the number in the middle here is big. 3 has factors of 3 and 1. Don't have any choices with that. I need a 14. 3 times 3 is 9. 5 times 1 is 5. 9 plus 5 is 14. It's these. That. You got to use that. So I'm going to do 5x and 3x. I don't want 15x. So I guess that wouldn't work. So I don't want to put the 3 down here. I want to put the 1 here. So I can get a 5x. And then if I put 3 here, that's going to be 9x in the middle terms. And those put together give me a 14. They both need to be negative so that the ends are this. The last thing is positive. Negative 3 times negative 1 is positive 3. And then add up negative 9x and negative 5x is negative 14x. So I take 5x minus 3, set it to 0, and solve. I get 3/5. I take 3x minus 1, set it equal to 0, and I get 1/3. Okay, 13 we need to set to 0 to start it. Divide by 4. All terms are divisible by 4. Let's factor out of 4. Factor the trinomial. Set the factors to 0 and solve. We get negative 4 and negative 1. Okay, they may still need this page. Okay, I did go kind of fast, sorry. I thought that was an easy factoring question after what I've already gone over today, so I kind of went fast. Okay, write a quadratic in standard form with the given zeros. There was a challenge question on the quiz yesterday before I taught this to see if maybe you could figure it out. I don't think, not too many people got it. It'll be on there again though as something you should know. remember this x minus p, that was a 0 times x minus q, the ones that you had to graph like that. Well, anyway, you can put in these as p's and q's. So this first one's really easy because it's just going to be parentheses x minus 2 times x minus 3. If you FOIL this out, x squared minus 5x plus 6. Now, I just did it the shortcut in my head. I did them in my head. Remember, that's just x squared minus 3x minus 2x plus 6. And I simplified it already. Okay, you could go ahead and multiply that by anything you wanted, and it would just become a skinnier parabola if you were graphing it, or fatter. But it would still have those zeros. Okay, you'd have to multiply every term. So this is just your simplest standard form quadratic with those zeros. This one, the first one's simple. We have x minus 4. But the second one, how do you solve, if you have a 0 that's, say this, how do you solve it? You subtract 2 and then divide by 3. So that's the solution, right? So if I want to go back to the factor, I would subtract the top number, and this number's got to be something we divide by. So where would it go? Yep. You with me? I hope you were paying attention just now. It's not that hard. It's just, and if you screwed it up and you haven't flopped or something, you can look at it and say, would I get that solution if I solved it? You know, if I set it to 0? Okay. So then we would FOIL this out. 2x squared minus x minus 8x plus 4. This would be 2x squared minus 9x plus 4. Okay, so one more time. The number on the bottom, you got to divide by that number, so it must have been attached by multiplication, right? 2x minus 3 times 5x minus 4. Four fifths. Just go back in your head and say, did I write it right? 3/2. Okay. Now I can multiply it out. 10x squared minus 8x minus 15x plus 12. 10x squared minus 23x plus 12. Okay, now more solved by factoring. I'm leaving these for you to practice. Well, I want to do certain examples still, so I'm going to hit this one. Those we already learned how to do, the ones I just skipped over, so you got a little bit left on that page. Make sure we get through our notes properly. We need to look at the area. Back in Geo, hopefully you remember that area was base times height, or length times width. So if the area is 36, we're going to pop in a 36 for the A. We're going to put in an x for the base and an x minus 9 for the height. By substitution, we're going to set it to 0 and distribute. Okay, so I subtracted 36 from both sides and distributed. Now I'm going to factor to solve by factoring. Factors of 36. Most of you think of 4 times 9, but don't forget about 2 times 18 and 3 times 12 and 36 times 1. What one do I need to add up to 9? What pair? Yep, 3 and 12. So x minus 12, x plus 3. I need the bigger one to be negative since that negative 9x is in the middle one. I should verify that it is the right factorization. A negative times a positive is a negative. Set the two factors to 0 and solve. I get x is a 12 and negative 3. Now, one of these answers makes no sense to the problem. This is a length. -3, okay. No. So the one you want is the 12. And then it says to find the dimensions. So that's going to be 12 feet. How I know it's in feet is because this area is 36 square feet. When you unsquare square feet, you get feet. Feet times feet is feet squared. All right, so anyway, we go, it's 12 by, and then we think, okay, wait, 12 minus 9. Oh, the other one is 3, but it wasn't -3, it's +3. Why don't you try the next one? Okay, I would think you're probably done. X times x plus 14, you should have had set to 15. You would have solved it by distributing and subtracting 15, and then factored it to x plus 15 times x minus 1. You would get a solution of 1, the only one that works, and then the thing is 1 foot by 15 feet. Good? All right, now I want to teach you factoring by grouping. Grouping, what might that mean? Well, get in a group. So I'm going to group things. I'm going to put pairs. So I'm going to group the first 2 terms and the second 2 terms. Now I'm going to factor out what's in common to the first 2 terms. I got a 4 and an m. And that gives me an m plus p. 4m times m plus p. The second pair of terms I'm going to factor. They have in common a 3 and a p. 3mp divided by 3p would be m, plus 3p squared divided by 3p would be p. Oh, looky. Something matches. That we're going to think of now. Think of this, guys. This is one ginormous term right here. Okay, it's a product. This is a ginormous term. It's a product. They're separated by addition, or attached by addition. They are married. Now, these guys were like just like them in a sense, except now this term is this big, and this term is that big. Okay? What they have in common is the m plus p. So we're going to factor it out, right? We're going to pull out the m plus p. Well, that to get back to what we had here, we just divided this big term by m plus p, which leaves us with a 4m. Plus comes down. This term got factored away and left me with a 3p. Now it's done. That is properly factoring by grouping. I factored away the common thing from the 4m and the 3p. Okay, group these, guys. So we'll go with the first 2 and the second 2. It doesn't always work that way, but most of the time it does. Sometimes you have to do some rearranging. Okay. What's in common to 3x and, 12ax and 3xz is 3x. 12ax divided by 3x is 4a. 3xz divided by 3x would leave me with just a z. Bring on the plus sign. The second pair have a y in common only, and that leaves me with a 4a plus z. Thankfully, something matches. What matches is 4a plus z. So we're going to factor it away from them. Factor out a 4a plus z, leaving us behind 3x plus y. Okay, let's throw in a tiny bitty little bitty curveball in the next one. We're going to bring out an a. Not much to factor here. This is a lot less complicated looking. You get an x plus y plus parentheses x plus y. Now, I just want to remind you of something. If I had 4a plus 4, you would factor out a 4 and tell me to write a plus 1, right? So what I'm trying to get at is you can't ignore the 1. It doesn't like disappear, right? You didn't take out the 4, you divided by it. So here, I have to factor out an x plus y. What am I left with? An a plus, how many x plus y's were over here? 1. Okay, here's another way to think of it. You can put a 1 in front of the parenthesis, okay? How do we feel about this? Not too bad? Some people find this easier than the other kind of factoring. Except when we get to more tricky ones. But let's do this one kind of quick, or go for it. Why don't you try it and see if you get it before I do. I'm not gonna, I gotta talk about 32 a little more. Okay, check verify your answer, please. How we do? Does anybody have this swapped? Okay. Okay, this next one, we got to be a little more careful because this minus sign right here. So think about this. If you put parentheses around that, you can put a parenthesis here. But what did you just do to that too as soon as you did that? Change the sign, didn't you? Okay, so you got to change the sign of this guy too. All right, now you change the sign or the meaning of the 2, so you have to change the meaning of the next part of this and what's in there. Now I can factor out an x squared. I'm going to get 2x plus 3 minus, all I got is a 2x plus 3. Okay, so next time, now we've got a common term of 2x plus 3. We factor away, bring it on out. What was left is an x squared minus something. What's the minus something? What's here? 1. Okay, but then, check it out. This is factorable. You got to go further. This has a difference of squares at the end here. So x squared minus 1 factors to x plus 1 times x minus 1. Okay. Whoa, here goes. This one's a crazy one. Now, check this out. What do these have in common? Well, they do have a 4, but no letter, right? What about these two? Nothing. So we need to rearrange it. Okay? So let's think about what might look better next to each other. How about if I start with the 12c squared x, then I probably want to put the one with the c squared near it. Okay, so let's do minus 16c squared y plus the 4d squared, and I'll just rewrite the rest of it, minus the 3d squared x. Okay, so this time I needed to rearrange just by inspection. If I had started putting the parentheses around there, you would have noticed it pretty quick. There wasn't much to do, okay? All right, so let's group these two and these two. Okay, in common are a 4 and a c squared. That would give me a 3x minus 4y. These two terms have no numbers in common, but they got the d squared in common, so we'll factor out a d squared. And check it out. We get 4y minus 3x. Uh-oh. They don't match perfectly. So what could I do to fix that, guys? Just change it? Just do it? No, you can't do that. We got to do something to allow ourselves to change it. So real quick, I'll be done here in just a second. This is my last example. I'm going to change the sign of these guys, which means I need to change this guy out here, okay? And now I can turn that around. You have to factor out a -1, people. I factored out a -1. All right, so now I got the answer. I'm going to do the common thing, the 3x minus 4y times parentheses 4c squared minus d squared. And guess what? The last pair is a perfect square trinomial. So this is about as bad as they're going to get, okay? Perfect square, 2c minus d times 2c plus d. Why are you packing? I don't know if I'm going to have time, but I'm going to try.